Okay, well, this is my presentation. I'm going to talk about Elixir, Kubernetes, and Minikube. And first about me, I am Miguel Cobá. You can find me on Twitter at Miguel Cobá_. Currently, I am a senior backend engineer at show.com. It's a company that specializes in software for small business like hairdresser, tattoo parlors, so that they can book the appointments for their customers and also receive payments through them. So that's what I'm doing right now. I am writing Elixir full time, so I am very happy because I like Elixir a lot. So why I like it? Well, we all know Elixir. Elixir, it's a nice language that is dynamic and functional. But the main thing is that leverages the Erlang virtual machine. The Erlang virtual machine, it is, or it was designed, and it is built for low latency, fault tolerance. And the main thing that mattered to us today is that was from the very beginning designed to be distributed. And this allowed us to do very interesting things, like, for example, clusters. Erlang clusters are a way to have distributed Erlang systems. This cluster of Erlang systems is named commonly or popularly an Erlang cluster, and it is no more than a number of Erlang runtime systems communicating with each other. Each node in this cluster is a running Erlang runtime system that has a name. Those nodes can connect and communicate with each other to pass information and do work together. So what is an Elixir cluster? Well, an Elixir cluster is just an Erlang cluster, but with a modern language on top of it. And also we can use this library named libcluster to easily create clusters. We can create clusters manually if we want, using Erlang or using Elixir. Any of those allow us to start nodes and connect them together and create a cluster. We can do that manually, but that is not very useful if we are trying to do something in production or something that needs to be automated. So libcluster provides automatic cluster formation. And the way it does is based on strategies. There are several strategies that you can use depending on how complex your scenario is or what kind of deployment you want to have. But today, we are just going to care about the Kubernetes strategies. So for that, we need to know or to talk a little about Kubernetes. Kubernetes is a technology from Google. It is now an open source project. And its goal is to automate deployment and also the scaling and the management of containerized applications. And this is the main, this is a very important thing. It only can run containerized application. We need to transform the applications we want to run in Kubernetes so that it is in the form of a container. The most famous container that we know is Docker. I think everyone or most people has heard about it, even if they have not used it yet. But Docker is very famous. It's a way to package applications and distribute them to anyone. So Kubernetes built upon that. So how can we learn Kubernetes? There are several ways. You can use some cloud provider like AWS or Azure or Google Cloud Platform, but those platforms have a cost. You have to create a subscription, sign up for a plan, and maybe pay for it. If you want to do it for learning, you maybe are not willing to pay, or at least not initially. So for that, we can use Minikube. Minikube is a way to run Kubernetes locally. And it is very easy to use it to learn and develop with Kubernetes. If you Google Minikube, you can find it, or you can go to this URL here. And today we are going to use that to create a cluster and deploy our Elixir application there. So let's move on. First, if we want to use Minikube, we have to install it. I have a MacBook, so I install all my software with Brew. So if you also have Mac, you can just do Brew install Minikube, and you will have it available for starting creating clusters. And with Minikube installed, you can create clusters. You can create any number of clusters in your local machine as long as you have enough resources, as enough CPU and memory to run it. But for one or two, I think any laptop is more than enough. So today I'm going to create a cluster named Elixir, and I'm going to specify 3 nodes. So I'm going to run this first command, minikube start, and passing the name of the cluster and the number of nodes to start the cluster. So here I have minikube start, the name of the cluster, and the number of nodes, 3 in this case. So this is going to take a while, and while this is running and pulling Docker images and setting our cluster and ready for us to work, let's continue on the slides, and then we will get back to this screen. So while this is while our cluster is being created by Minikube, let's talk a little about some Kubernetes concepts that we need to understand. Those are very basic ones. The Kubernetes is a huge technology. There are a lot of things, but you to understand Kubernetes, you only need to know 3 things. The first one is the cluster. A Kubernetes cluster is just a set of worker machines, and each of these machines is called a node. A node is a virtual or a physical machine, depending on what you have. You can have a mixture of virtual and physical machines. And the last one is the pod. The pod is a group of containers that share storage or and network resources. And this is the most important thing, because the pod is the thing that runs our container. So when we create our Elixir application, we are going to deploy it in a pod. And this pod is going to run inside a node. So what we have is a cluster made of nodes, and the nodes run pods. So if we check this, is still running. Let's continue here. So what we are going to do, we will have a cluster ready for our application to be deployed. So we are going to create a very simple application, simple Elixir application. The application is going to be called Curiosum Meetup. I'm going to install the dependencies and ask to not configure the database, because we don't need it today. It's just going to be a web app without any storage. Then I'm going to generate some release files. These are the files that allow us to generate an Elixir release from our application. And as I am passing this Docker flag here, I am also requesting to generate a Docker file. Previously, until last year, we had to create this Docker file manually, but now Phoenix automatically can automatically generate the Docker file for us, and we can just use it. It's very easy to do. And the final step that I'll talk later is configure this Elixir release so that it can work with lib cluster to form a full Elixir or Erlang cluster. So let's start with the first one, and let's create the application. I'm going to run this mix phx new. And sorry, where is my screen? Here. I'm going to open a second screen here, a second terminal. And I'm going to copy this command. Oh, sorry, I already had it here. Okay, I have here my command. So I'm going to run this command here. This is about to finish. I think I can wait for this to finish. Yeah, okay, it is on. Let me move this thing here. So Okay, the cluster is finished. It is a lot of messages are here, but the main thing is that we have 3 nodes, and the cluster is ready to be used. Before using the cluster, there is another command that we can use to configure what is the default cluster we want to work when we send Minikube commands. Is this one, Minikube profile Elixir. So I'm going to just run that so that I don't have to specify always the name of the cluster. So with that out of the way, let's now create the application very quickly. I'm going to clear the string and create the application. This is going to download the, oh, sorry. Okay, I'm going to create the application. This is going to create the application named Curiosum Meetup. Then I'm going to move inside the application and run the second command. The second command is this one, to generate the release file. So I'm going to run the second command here. I'm going to copy the command from my other screen. And once this is finished, I'm going to generate those files. It's almost there. And the way that the Elixir releases works is by using some file templates to control how the Elixir release starts. And with that, we can control how we name the nodes and how we start the Erlang node. So we need to do that in order to lib cluster to find the nodes. So here, once this finish, I'm going to run that command, and we will start looking at the template files. Okay. Come on. Okay, let's continue with the slides. I will go to the next slide. So after that, we need to generate the template files that I was talking about. The main one that we are going to modify is this one, n.sh, because this is the one that runs just before the Erlang virtual machine starts. In that file, we are going to set the node name. So with that, let me just see. Okay, it was on. Okay, here it is finished. I'm going to move to folder and run the second command. This is going to generate the Docker file. I'm going to initialize Git so that Visual Studio Code honors the git ignore file. And now I'm going to move to Visual Studio Code. I'm going to increase the font size so that you can see it better. And the first file I'm going to open is this one, NSH. Oh, no, sorry. No, I just run the Docker file. So this is the Docker file we are going to use to generate the container image. So I hope the font size is correct. But the main line that we care about this Docker file is this line on line 65 that uses the mix release command to generate the Elixir release. And then it's going to wrap everything in a Docker container. So this is the Docker file. I'm going to run the release init here. And this is going to generate 4 more files, but the one I care about is this one, NSHEXS. This has some template, some boilerplate here. I'm going to replace that for some code that I have here. If I click this button, I will open this this file. So I'm going to replace the contents of that file for this, and I explain what this is going to do. I'm going to replace all of this for this. What is this going to do? What is this doing? First one is using long names to name our node or Erlang node, and then it is setting the name of the node to this. It has two parts. The first one is the release name. The release name is our application name, in this case, Curiosum Meetup. And the second part, separated by the ampersand, is this environment variable that is going to be used here and replaced by its value. And as the name it says, is going to have the pod IP that Kubernetes assigned to this pod when it starts. So if I create a cluster with 3 nodes, as we just did, we are going to have 3 different IPs, one for each pod. And Kubernetes is going to pass this IP to the pod when it runs inside an environment variable, and we are going to take that environment variable and use it here to generate a name. So at the end, we will have an Erlang node with this format. So this is the first part. The second one is we need to add libcluster to our dependencies. So let me add this here to our mix file. Here, add this and then run mix let's get. So this is going to download our dependency. Then we need to configure the strategy that libcluster is going to use. So I'm going to open this file, config.exs, and copy this fragment here. This is the configuration for libcluster that I am going to use to configure my cluster. So here, at the end, I'm going to add this configuration, and this is going to be used to configure libcluster. The main thing here is the strategy that I picked. I am using Kubernetes DNS. This strategy requires one service of type headless to exist inside Kubernetes, because libcluster is going to contact this service to ask, hey, which are the IPs I need to contact so that I can form an Erlang cluster using the Erlang nodes in each of those IPs. So this headless service is going to answer, in our case, with 3 different IPs, and then libcluster is going to contact all of those 3 pods, and with them is going to form the cluster. And finally, is this application name. We are using the same name as our application. So this is the configuration for libcluster. Finally, we need to start the cluster supervisor, because otherwise this is not going to work. I'm going to start the cluster as a child of the main supervisor in our application. So if I go here to the application EX, I will copy this here and replace here this part. Okay, what I am doing here is I am reading from the environment this libcluster topologies. This is the one that we set up here, libcluster topologies. So all this configuration here is going to be read here, set in this binding, and then let's wait for this full screen to disappear. And then this topologies configuration is going to be used to configure the libcluster supervisor, and that is part of the children of our application. So it will be started at the beginning. So now the application is ready to be part of a cluster. So there are 5 files we needed to configure. First, the Docker file, so that we get a container from our application. Then the MSH, so that the names of our nodes are correctly built using the IP of the pod. Then our dependency, libcluster, that we configure here using the Kubernetes DNS. And finally, we started the supervisor. So that's it. With this, we can deploy to Kubernetes, and we will have a cluster. So let's do it. But before going to that, you can do that manually, or you can just clone this sample repository here. I already did that. So instead of using this one that I just modified now, I'm going to move to the repository that I cloned from my GitHub account. There is one extra change that I did in this application is I modified the page controller so that I could get the node information and the list of nodes known by this node so that I can show them in the default homepage for the application. I am passing them to the index HTML and just presenting them into columns. One column for the current node. Let me close this. And another column for all the other nodes in the same cluster. So this is the application I'm going to use. All the other changes are exactly the same, so we can continue. So we have our application ready to be transformed into a container that we can use to deploy to Kubernetes. So for that, I need to build a container from this application. I'm going to use this command, docker build, and I'm going to tag my image using this name, Miguel Cobá Curiosum Meetup. And I am using this number. You can use any number, any name for your own images. But later, when after my image is created, I'm going to push that to Docker Hub. And for that, you need to have an account in Docker Hub or any other container repository. I have one created here in Docker Hub. You can see it here. I have created this Curiosum Meetup repository. Right now it is empty, no images are there. So I'm going to push, I'm going to build my image and push my first image here, and we will see it here in the tags section. So let's create the image. I'm going to build the image with this command. And the Docker is going to look at the Docker file that Mix created for us and create an image. The image is created and it has a checksum here. Now I need to push it. I need to push it to Docker Hub. I'm going to use now the Docker push. Let me clear the screen. Okay. I'm going to push my image to Docker. So now it is pushed. And if I go back to Docker push and refresh this screen, this page, we will see now here, this is our first tag, just a few seconds ago. So now we have our container image in a public repository where Kubernetes can go and fetch it. So let's go to the interesting part. Let's continue now to Kubernetes. So deploying to Kubernetes requires several resources to be created inside Kubernetes. Kubernetes has several types of resources, but we are only going to use three. The first one is a headless service. If you remember, I'm going to minimize this one, and in the config X, we put this service name, and it needs to be a headless service. So we are going to create this headless service. And what is a headless service? Is a service that it is only accessible inside the Kubernetes cluster. A Kubernetes cluster by default is isolated from the world unless you explicitly allow access to it. So this headless service is going to be accessible to all the other resources inside the cluster. And as I said, it will be used by the cluster to find the Erlang nodes. But this doesn't create any pod. It only describes which pods are going to be part. So I have already prepared this Elixir headless file. Let's check it. And it's very simple. it has some customary keys here. What we care about is the name. This is named called Curiosum Meetup Headless, as we specified here. Curiosum Meetup Headless. The type is service. The kind is service, and the type is cluster IP, and cluster IP is known. These three things, this kind, type, and cluster IP, are what configures a headless service. So this is going to find all the pods that need to be returned when lead cluster asks for the nodes that are going to be part of the cluster. So now I can apply this configuration to my Minikube cluster. So there is this command line tool called kubectl, and it has a command apply where that I can specify a file name. I'm going to specify the headless file, and I'm going to apply it. So it's going to take this file and it's going to apply it to the cluster. How Kubernetes works is we declare what we want, and Kubernetes takes care of making it real or making it work. So I'm going to check if the service is created with this command, kubectl get service, and we can see here that 20 seconds ago, this service was created. But as I said, no pod was created, and we can verify this with kubectl get pods. There are no pods yet. Let's continue. We have the first service. The second one is to create the pods. Let's now create the real pods. The pods are going to be created using an image, a container image. So this is where we are going to fetch our Kubernetes or Elixir image and create the pods with it. I'm going to run this command, but let's here see what it has inside. This is, again, some specific Kubernetes things. But what is important here is this replicas that is set to 3. This specifies that it's going to create 3 pods. Each pod is going to be identical, and all are going to use this image. This image by default is going to be fetched from Docker Hub. So in Docker Hub, it's going to go to my repository and look for this tag 1.0. And the other thing is I'm setting these environment variables. When the pod starts, Kubernetes is going to create these environment variables and inject them to the pod, so that when our application starts, it will find these environment variables with this value. The pod with 4,000. And this is interesting. Here is the pod IP that we talked at the beginning. We said that Kubernetes is going to assign the IP of the pod and as a value for this environment variable. And it does that using this value from key. It takes the pod assigned to the IP assigned to the pod, and with that is going to populate these environment variables. So at the end, we will have 3 environment variables when our application, when our pods run. So let's run it. Okay, I'm going to run this. I'm going to clear the screen and run it. Okay, now this is creating the pods. Let's check. And as you see, it is still creating the pods because it is fetching the image from Docker Hub. It is starting up and doing a lot of things. But if we refresh this, at some point we will see here that the status changes to running. When that happens, our application is ready to be used. So what's next? Let's wait for that to finish and let's continue. So as I said before, a cluster is completely isolated unless I explicitly allow access to some resource. So for that, I'm going to to be able to access our Elixir application, we need to allow access to it. So I created this other service, Elixir service YAML. I'm going to open it here. And this is also a service, but the type is different. This is a load balancer. A load balancer is a service that is exposed outside the cluster. I am exposing the port 4000. I am also forwarding every communication from this outside port to the same port in the pods. So with this, I will be able to access the cluster using this port 4000, and it randomly is going to hit one of the pods that are running our Elixir application. Let's see the status of the pods. Okay, so as you see, the status has changed to running. That means that our cluster is already running. I haven't yet exposed the service. I'm going to first do something. Let's just check that the cluster was formed. I can go and connect directly to one of the pods using this command, kubectl exec. Let me clear the screen so it's clear. I'm going to connect to the first pod. This is the name of the first pod, and execute a bash session. So this is going to connect me to the first pod. I am in the shell. You see here the files that the Elixir release generated, and here I am going to use the Curiosum Meetup remote command to connect to the Erlang virtual machine, to the node. I'm going to run this one, and I am now inside the node that is running inside the pod, inside our cluster. A few things to notice. Here is the name of the node. You can see that it is following the format we specified in the Elixir application. The Curiosum Meetup is the name of the application, and then the IP. This is the IP that the Kubernetes cluster assigned to this. Now let's check which other nodes are part of the cluster. And yeah, we have the other two nodes. One in this IP, 1.2, and the other in this other IP. So we have three different IPs corresponding to three different pods, and all those three were automatically connected by the cluster. So we have now a cluster. We are almost done. The cluster is ready. I'm going to Control-C here and get outside, log off from the pod. I am again back in my local machine. So I'm going to expose the service so that we can access the Elixir application using this port. I'm going to clear this here. I'm going to run this command, kubectl apply Elixir service. So this one is going to create a new service of type load balancer. Let's check. Get service, and we can see here that there is a new service. This one, Curiosum Meetup service, is its type is load balancer, and this one is going to be exposed to the world. But for that, it needs an external IP to be assigned, and in this case, it's pending. So we need to wait for this to assign an IP. But as we are running this in Minikube, we don't have public IPs to connect to our cluster. If you were running this cluster in AWS or Azure or Google Cloud platform, you will see here a public IP assigned to you. And if you go to that IP and port 4000, you could access your Elixir application. But in this case, we don't have an external IP. If I refresh, the status is still pending, because Minikube is not going to assign never an IP for us. So how can we connect to our application? Well, Minikube has a tool called Tunnel that it will emulate this behavior in our local machine. So I'm going to do that here. I'm going to open a new shell and run here Minikube tunnel. I don't need to specify my cluster name because previously I set the Elixir name as the default cluster, so I just need to run here Minikube tunnel. This is going to look for all the load balancer services inside the cluster. We only have one, and it's going to expose it to the world. So let's get back here and refresh this one. And as you see, now we have an external IP. Of course, the external IP is just our local host, but now we can access in this IP and this port our application. So let's try it. I'm going to open a local host 4000. This is our cluster, and we are done. We have our cluster exposed to the world is running inside Kubernetes. It has 3 nodes. This is the node that this request I did with the browser. This is the pod that respond, and these are the other pods that exist on the cluster. I'm going to refresh very quickly this so that we can see the IPs here change. You see it is changing because the load balancer is doing its job. It's load balancing the request so that it hits different pods every time. So you see here that it is hitting different pods. So that's it. Our cluster is ready. One last thing. Let's see how to scale this. If you remember here in the deployment, we specified that we have three pods, 3 replicas. Let's change this to 6, for example, and let's apply it again. Let's apply again this. I'm going to clear the screen again. I'm going to apply again the same configuration, but this time the replicas has a value of 6. I hit enter. If I kubectl get pods, you'll see that now we have 6 pods running in our cluster. The 3 original ones are still running here, 8 minutes. But 3 new ones are being created right now. It's going to take a few seconds to finish. And when they are done, okay, now they are done. All 6 are running. So our cluster now has 6 nodes. I'm going to refresh here the screen, the page, and now we have 6 nodes here. If I put a 4, it's going to be reduced to 4 and to any number of pods you specify, as long as the cluster has enough capacity to do that. So what's next? I don't know how is our time. I think we are already past the time. Yeah, I think, okay. Well, I think we can stop there so that we don't go over time. But if you go, just to finish, one more minute, if you go to the repository, you will see that there is an additional file here. An additional file here called Elixir deployment secrets, that instead of using directly the values here in the environment variables, because this is sometimes not convenient. For example, if we have the password to our database, we don't want to have that password committed to a repository and pushed to our Git repository, because everyone with access to the repository will see the password. So in those cases, Kubernetes allows us to create a secret resource where we can set those values, and then in our deployment, we can, in this one, we can, instead of putting there directly I'm going to split the screen here. Instead of putting directly the plain text value, we will just reference our secret resource and the key under which it is our secret. And when the pod it is started, it will get the information, the sensitive information from that secret. And then we can safely commit this file to our repository and not be in risk of leaking some sensitive information. So that's it. Let's get back to Michal. I don't know if you are there. I see there are some questions here.
So thank you for the presentation, and I'm gonna switch on the Q&A mode for the presentation for a moment, so we can answer a few of them.
Okay, so okay, yeah. First question: do you read it or should I do it?
All right, so I've got a question from Yatin. I have mostly worked with Java and I'm new to Elixir. When you say Elixir is distributed by nature, does that mean one process on one node can by default talk to another node's process without any external mechanism required?
Well, as long as the nodes know each other, they can communicate. Erlang and Elixir communicates by sending messages. So as long as you know one node knows the other node, and you know, and you send messages to the other node, and the other node is listening to those messages, you can communicate. But it is some work you need to do, but it is super easy compared to Java, for example. But yeah, it's quite baked in on the language and on the virtual machine. As long as the nodes are connected, you can send messages between the nodes.
All right, thank you for the answer. So we've got another question from Ahmed, who's asking whether exporting these environment variables is required by libcluster. I think it requires to I think it relates to a specific point in the presentation, right?
For releases, Elixir releases, it is controlled by environment variables because this is going to work in a different machine that you are working in. So the best way to control how the application is going to start, or how where the database URL is and things like that, is better to pass them through environment variables. And for libcluster doesn't really need any environment variable. Some of the strategies require some information to be passed. For example, there is a gossip strategy that works by broadcasting. Every time a new node starts, it broadcasts, "Hey, I am here, I am ready to work." And all the other nodes hear this broadcast in the network, and they can connect to the same cluster. They can include it in the cluster, in the Erlang cluster, as long as they share a secret. And that shared secret can be passed as an environment variable. You can hard code it. You can always hard code things in your application, but when you start moving to production environments, you start extracting information to environment variables, because it is very easy to create or to have more flexibility in how do you start the application. So even if it's not required by libcluster, it's very useful to pass information in the form of environment variables.
Okay, I think this pretty much answers this question. So thank you very much. And another question from Ahmed is that if we have 3 instances of the app, how can you guarantee that if our app, for example, runs periodic jobs, it will be run only once?
Yeah, Kubernetes, well, depends. If you are talking about an Erlang node, an Erlang cluster, for example, there are some libraries to do this, to ensure that only one application, only one node runs, for example, a gen server or some other agent or some singleton that is in charge of these periodic jobs. So you can use some Elixir libraries to do that, to ensure that only one of all the nodes in your Erlang node runs this kind of application, so that it has full control and nobody else is doing the same thing at the same time. If you do that in Kubernetes, Kubernetes has also a way to run periodic jobs. And for this, I think I have never used it, but it runs a separate container, a separate pod, just to run this kind of periodic jobs. So again, you ensure that only one node is in control of these tasks.
Yeah, and I guess if you want to scale this and not have just one node in charge of the background jobs, you can think of some scheme to partition the data, right? So yeah, kind of deterministically, specifies which data will be handled by which, let's say, worker in this case, right?
Yeah. Correct.
Okay. Thank you for this question, and we have yet another one from Pavel. Pavel is asking how to deal with network partitions when running a globally unique process. With a static cluster, we can use Swarm with static quorum strategy. And what about dynamic clusters? Is there any equivalent to akka split brain resolver with Kubernetes lease strategy?
Well, to be honest, I don't really know. I have never used Swarm, and I don't know akka either. So sorry, I have to say that I don't know how to do that. It's a very specific question, but I don't know. I don't know if you, Michal, have an idea about this.
Well, I've used akka a few years ago, but never really got to that point of expertise. So I don't think I will answer this, unfortunately. Yeah, not much of a Kubernetes expert right now. So I think we'll have to leave this unanswered for now. But I think this is a good topic to investigate.
Yeah.
Okay, I think that's all for the Q&A, and that's all for Miguel's presentation. So thank you very much.
Thanks to you. And before just 1 minute, I have a surprise for all the attendants. I'm going to give away or to do a raffle of my book to one of the attendants. So I think the easiest way, I don't know if there is a way to get a list of all the attendants to the meeting, but in the chat I see that there is a way to export the chat contents. So if everyone just put a message in the chat, we can export the names and we can do the raffle with all of them. Okay, so just write something in the chat and we will get the unique names and then pick one at random. And again, thank you very much for having me. It was very fun. I hope I didn't bore you so much. And just thank you.